Hello and welcome to my YouTube channel. I am Dr. D.M. Chavan, Assistant Professor in Chemistry. Today I discuss with you about the optical isomerism. Before going in detail about the optical isomerism, I would like to say something about you, that is why it is necessary to study the isomerism in the chemistry. To answer this question, please look at this picture. This is the picture of children who born due to the birth defect caused by the thalidomide drug. Thalidomide is the drug which was used by the pregnant women to recover from the morning sicknesses, but the company who marketed this drug, they were unknown about the existence of the two isomers. Now this is the birth defect caused by the thalidomide drug. We discuss about what is thalidomide. Thalidomide drug exists into the two optical isomers, that is R isomers and S isomers. Out of these R and S isomers, only R isomer is the bioactive, whereas the S isomer is the lethal effect to the newly born baby. Due to the consumption of these racemic mixtures of R and S isomers, the S isomers develop the birth defect in the newly born children. This picture gives the answers why it is necessary to study the isomerism. To avoid such a tragedy in the future, it is very much necessary to study the isomerism in the chemistry or in the developing drug. Now what is isomerism? The compounds having same molecular formula but different physical and chemical properties are known as the isomers, and the phenomenon of existence of this is known as the isomerism. For example, the butane. Butane is the molecular formula C4H10, but it exists into the two forms, that is N-butane and isobutane. Both these molecules, that is N-butane and isobutanes, have same molecular formula, but they are exist into the two different forms. These are the isomers of each other, and the phenomenon is known as the isomerism. Now what are the types of isomerism? Isomerisms mainly of two types, that is structural and stereoisomerism. Structural isomerism are classified into the chain, positional, functional, metamerism, tautomerism and ring chain isomerism. Whereas stereoisomerisms are of two types, that is optical isomerism and geometrical isomerism. Out of all these isomerism, we are only discuss about the optical isomerism. Now what is the optical isomerism? The isomers that can rotate plane polarized light are called as optical isomers, and the phenomenon is called as optical isomerism. Now what is the plane polarized light? We know that the ordinary light vibrates in all directions, but when the ordinary light is passed through the prism, then differently vibrated light are vibrate only in the single plane. Such a light is known as the plane polarized light. The plane polarized light whose vibration occurs only in one direction, therefore it is known as the plane polarized light. The diagram explains well. Now what is the optical activity? The compounds which have the ability to rotate the plane polarized light either to the right or to the left is known as the optically active compounds, and the phenomenon is known as the optical activity. Now rotation of the plane polarized light. The following figure will explain the rotation of the plane polarized light. When we pass a plane polarized light to any substance, that substance can rotate the plane polarized light either into the right direction or into the left direction. Such phenomenon is known as the optical activity of that substance. Now what are the different types of optical isomers? On the basis of directions of rotation of the plane polarized light, the optical isomers are classified into the two types, that is dextrorotatory and levorotatory. Now what is the dextrorotatory? The optical isomers which rotate the plane polarized light in the clockwise direction or to the right direction are called as dextrorotatory and denoted by D sign or by plus sign. Now what is the levorotatory? The optical isomers which rotates the plane polarized light to the left direction or into the anticlockwise direction are known as the levorotatory, and it was denoted by the small l sign or by the minus sign. Now what is the asymmetric carbon atom? We know that carbon have the 4 valency, and if that 4 valency of that carbon is satisfied by the 4 different atoms or different groups, that carbon atom is known as the asymmetric carbon atom. In the following example, the carbon attached to the 4 different atoms, therefore this carbon is the asymmetric carbon atoms. Now what is the asymmetric and chiral molecule? Any object which is not superimposable upon its mirror image is the chiral. For example, right hand is the mirror image of the left hand, but the right hand mirror image is not superimposed on the left hand mirror image. Therefore, this object is known as the chiral object. Now take the another example, conical flask. When we put the conical flask on its mirror image, they are directly superimposed. Such an object is known as the achiral object. Now what is the element of symmetry? In nature, we observe the symmetry everywhere. For example, starfish. Starfish is symmetrical. We know the Taj Mahal is also symmetrical in nature. Butterfly is also symmetrical. Means the nature always loves the symmetry. In nature, symmetry is everywhere. Likewise, in the organic compound, there are also the symmetry. But in the chemistry, there are 4 different types of symmetry. That is plane of symmetry, center of symmetry, axis of symmetry, n-fold alternating axis of symmetry. We discuss one by one. Now we discuss the plane of symmetry. As the name indicates, the plane of symmetry, when we pass an imaginary plane through the molecule, if that plane divides the molecule into the 2 equal parts, then that molecule is said to be, it possesses the plane of symmetry. For example, the acetone molecule. When we pass the imaginary plane, then it divides the acetone molecule into the 2 equal parts. Therefore, the acetone possesses the plane of symmetry. Now, what is the center of symmetry? Consider this molecule, that is ethylene. When we draw a point in the center of that molecule, and if we draw a line and extend that line into the opposite direction, if we obtain the same elements, then that molecule is said to possess a center of symmetry. Now what is the axis of symmetry? When we pass an imaginary axis through the center of molecule, and if we rotate that molecule by 180 degree, and if we obtain the molecule that is identical to the original, then such a molecule is said to possess the axis of symmetry. For example, water molecule. When we rotate the water molecule by 180 degree, then we obtain the molecule which is identical to the original. Therefore, the water molecule possesses the axis of symmetry. Now, what is n-fold alternating axis of symmetry? To understand the n-fold alternating axis of symmetry, consider this molecule. When we rotate this molecule by passing the axis through the center, and if after rotation, if we take the mirror image of that molecule, if the mirror image after the rotation of the molecule is identical to the original, then this molecule said to possess the n-fold alternating axis of symmetry. Now we discuss the enantiomers or enantiomers. Now what is the enantiomers? The optical isomers which are non-superimposable mirror image relationship are known as the enantiomers, and the phenomenon of existence of the enantiomers are known as the enantiomers. For example, plus lactic acid and minus lactic acids, they are the enantiomers of each other. Also, the D-glucose and L-glucose, they are also the enantiomer, because the D-glucose is not superimposed on the mirror image of the L-glucose. Therefore, they are the enantiomers of each other. Now we discuss the diastereomers. Now what is the diastereomers? Diastereomers that are not mirror image of each other are called as diastereomer. For example, the tartaric acid. The tartaric acids are exist into the 4 different isomers. We label it as 1, 2, 3, 4. Out of these 4 isomers, first and third, they are the not mirror image of each other. Therefore, they are the diastereomers of each other. Likewise, the second and fourth, they are also not mirror image of each other, but they are the different molecules of the same chemical formula. Therefore, they are the diastereomers, and this phenomena is known as the diastereomers. Now, what is the basic difference between the enantiomers and diastereomers? The enantiomers are the optical isomers which are not superimposable mirror image relationship, whereas the diastereomers are the different molecules of same chemical formula, but they are not mirror image each other. This is the only difference between the enantiomers and diastereomers. Thank you for watching my video. Thank you very much.